Hey there. I was about to give intro for my other YouTube channel, the real one. I was thinking about it a minute ago, and I was about to say there, hey there, nomads of lore. If you've never seen Mead and Mischief, you should go check it out. It's like a whole real YouTube channel and everything. But in this video, we're going to be learning some math. We're going to be talking about writing linear equations. This is a topic that is taught usually pretty well in an Algebra 1 class, and so this is going to be review. Again, this is pretty much going to be completely review, honestly, from Algebra 1 topics. So we're going to start by reminding ourselves, I think we talked about this in an earlier lesson, but we're going to remind ourselves again what the slope-intercept form of a line is, right? So the slope-intercept form of a line is y equals mx plus b. And actually, this is the only form that we're going to talk about in this video. We're gonna actually kind of we're going to leave out point slope. If you are curious, excuse me, about point slope, or you would like to use it and you remember using it and liking it in Algebra 1, you can go and hop over to the Algebra 1 point slope video and watch kind of the first bit of it or whatever, and it'll jog your memory there. But we're going to, for simplicity and for streamline's sake, we're going to just talk about one type of form. So to remind ourselves, again, this is kind of review of a review, but the m is the slope, right? Slope, and the b is the y-intercept, right? So now that we've got that review out of the way, let's just jump straight into an example. So we're gonna, the title of this lesson is writing linear equations. So that's going to be all the types of problems we do, where we're given some information and we have to write the equation, right? So we're going to start by writing an equation of a line that passes through this point right here, 6, -2, and it has a slope of -4. And so ultimately, we're going to try to write a line in that y equals mx plus b slope-intercept form, right? And so we just got to kind of start plugging in pieces. So this is the point, may or may not remember what to do with that. The slope is easy, right? The slope is easy peasy lemon squeezy, right? The slope just has to go and pop where the slope goes. No big deal, right? So if we rewrite this equation with what we know without any effort, it would be y equals -4x plus b. So what do we still need? Excuse me. What do we still need to find out to figure out the equation? Well, we need this b, right? In the end, x and y are going to stay x and y. So what can we do to find the b? Well, we are given this point, right? And so what we could do is, and what we're going to do is, we're going to take and we're going to plug this point in there. Where would we plug it? Well, points go x, y, right? And so we're going to plug the x where the x is and the y where the y is. And then we'll get to solve for b. So let's do that. So we're going to put parentheses. It's just the same old substitution property that we've done over and over at this point, and we'll continue to do over and over again in the future. Put parentheses everywhere there's a variable, except this one we're going to leave as a b, because that one we don't know anything about. That's what we're looking for. So it stays a b, right? So now, in for y, let's plug in that -2. All right, so we're going to put a -2 right there. And then for the x, we're going to put that 6. And then we're going to take and we're going to solve this thing for our b. No problemo. So what are we going to do? We're going to multiply -4 times 6, which is -24. Bring down our plus b. What's attached to the b? The 24. It's negative. We're going to add 24 to get rid of it. Cancels right there. So then b equals 22. Now, it'd be easy. The number one on this kind of problem that's really pretty easy and pretty straightforward, the number one kind of mistake that you might see is, excuse me, is that you might have somebody, you might stop here, circle this, and then move on. But we've still got to do one more thing. We're not quite done, because we're supposed to write an equation, right, of the line. This is an equation, but it's not of the line and whatever else. So we're going to write our final answer. So it's going to be y equals, and then the slope, which was -4, -4x, and then plus b, and we just found out our b is 22. So we're going to do plus 22. Blapo. Done. Okay, next one. Whoa. There we go. So write an equation of the line passing through both of these points. So this time we're not given the slope. We're not given the b. We're not given nothing. All right, so what do we need to do? Well, we just remembered in a previous lesson recently that if we're given 2 points, we can find the slope between them with the slope formula, which has been pointed out to me by a student that I wrote wrong in a video. I apologize about that recently. Maybe eventually someday when I get all the videos done that I need to get done, maybe I'll remake that one and I'll fix it. I don't know, but not today. So today we're going to remember that the slope formula is m equals y2 minus y1 over x2 minus x1. That's what we're supposed to be there. We're going to plug these guys in there and we're going to find the slope. So let's do that. M equals parentheses minus parenthesis all over parentheses minus parentheses. Easy peasy lemon squeezy. Plug it in. Let's go ahead and label these so it's going to be easier to see and remember what we're doing. Let's say this is x1 and this is y1 because it's the first point listed. That works. And which would make this x2 and y2, right? Excuse me. So we're going to come in here and y2 was -3 and y1 is 7 and x2 is 3 and x1 is -2. So we've got minus here. So the very first thing we want to do is we want to ka-chink those, right? And turn that into plus. Now, we've got -3 minus 7. The signs are the same. So we add and keep the sign. So it's -10 over 3 plus 2 is 5. That reduces. And we find that m equals -2, right? Now, we found a thing. It'd be tempting to circle and move on, but we're definitely not even close to being finished. Now, so what are we going to do next? Well, now we're going to kind of revert back to just that last example because we basically have the same thing. We have a point and we have the slope. Now, the question is, which point to use? The answer is yes. You can use, and what I mean by that, of course, is that it doesn't matter which points you use for this next part. You can pick either one of them. Pick it, whichever one looks easier. These are both 3s. I'm going to pick that. I don't know which one would be easier in this circumstance, but that seems as good an idea as any. We're going to use y equals mx plus b. So we're going to plug in for y. We're going to plug in this guy. So we're going to let's go ahead and do some parentheses. Blap, 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 plus b. Over here, we're going to plug in y as -3. The m we just found is -2. The x we're going to plug in is 3. So it doesn't matter which one you pick as long as it's both things from the same point, right? So now what are we going to do? We're going to do multiplication. Bring down the -3 equals -2 times 3 is -6. Bring down plus b. Excuse me. So how do we get rid of the -6? Well, of course, we're going to add 6. Do it to that side. We've got to do it to this side. Blapo. So b equals 3. Of course, we're not done yet. We've got to write our answer. The answer would be y equals m, so -2x, and then plus b, which we just discovered was 3, so it's plus 3. Wow. Okay. This is kind of notes, and we're going to do one more example, and then we're going to quit. So parallel and perpendicular lines. This is kind of the first slightly tricky bit that we're talking about. So the first thing we're going to start is what are parallel lines and what are perpendicular lines? Well, this is easy, right? All right, we just gotta remember it and remember what's going on. So parallel lines are, of course, lines that never touch. Which is true. Look, now they're parallel because I labeled them so, right? They're clearly not quite, but close enough. And I said they were, so they are, right? So parallel lines, what's important for today's lesson no. I'm not going to the dentist because I'm making this video for you. So it's fine. They'll clear out their schedule. It'll be okay. Anyway, like I was saying, so what's important for us is got to go back to that slope intercept. So two lines being parallel must tell us something about the lines, the two different lines, right? And what it tells us is, let's say if we have, this one has M1 and this one has M2. If two lines are parallel, what's true about their slopes? Well, they're the same. They have the exact same rise over run. They have the exact same slope. So for parallel lines, they have the same slope. So M1 is the same as M2. They have the same slope. So if you're given a problem where it says find the equation of the line that passes through some point and is parallel to blankety blank, then the way you'll use that is you will be given the slope because it'll be the same as the slope in that other line, right? So what about perpendicular lines? Obviously, they're a little trickery. What are perpendicular lines? Perpendicular lines are specifically lines that cross at a 90-degree angle, specifically. All right, let me turn this on silent. I forgot to do that, and it's irritating and distracting. There you go. I apologize. There we are. Okay, so perpendicular lines are lines that cross at a 90-degree angle. That's what they are, right? So again, it's going to tell something about the slopes. So what's true about the slopes here on a perpendicular line is they are opposite reciprocal. Oops. Reciprocal. They're opposite reciprocal. So you flip it over and you change the sign. So M1, so the way we'd write that in sort of math is that M1, so the first slope is the same as negative, so the opposite sign, right, of 1 over M2. So they're opposite reciprocal. So you flip them over and you change that sign. So let's do an example with one of these. I keep doing that. There we go. All right, good to go. So we're going to write an equation in slope-intercept form for the line that passes through this point and is perpendicular to the line with this equation. So what is the fact that our line is perpendicular to that line? It tells us something about the slope, right? So this slope, we'll call it M1, is negative 3 over 2. So since they are perpendicular, they are the slope of our line, our M2, for lack of a better description, is this flipped over and the opposite sign. So it was negative. So our slope is positive, and instead of being 3/2, it is 2/3. So that's the slope that we're looking for. So this the slope of the line that we're looking for is that line. Now, one mistake I get sometimes on these, or I don't know, actually, I don't know that mistake is quite the right word, actually. One place of confusion, when people hit a problem like this, they get confused because they're like, well, this isn't a line. That's the answer. What are you talking about? This is stupid. Why? But that's not right. And the intercept, as you're going to see, is going to be different. In this case, a perpendicular line, the slopes are different too, right? And so just, I don't get confused that we have a line. All we're pulling out of this line is we're using that slope, right? And so that's important to kind of keep that concept and understand it. So now we're going to do the same thing we've already done twice, because we have the slope and we have a point that our line goes through. So we're going to just plug it in and we're going to be done. So we're going to use slope-intercept form. Y equals mx plus b for the third time. And we're going to substitute stuff in there. Plus b, and we're going to solve for b. So we're going to plug the y from this point. Right? So we're going to plug -6 in here. We're going to plug the m that we just figured out was 2/3. We're going to plug in the x from this point and put a 5 right there. Oh, we got some crazy fractions as we're going to get to have some fun with this one here. So we're going to do, excuse me, we're going to start out with multiplication. 2/3 times 5 is 10/3 plus b. Bring down the -6. How to get rid of the 10/3? Where we're going, it's positive, added. So we're going to subtract 10/3. Now you could, of course, pull out your handy dandy calculator, use the fraction button. You could also quickly scratch paper and multiply this times 3. And so we've got -18/3 minus 10/3, right? And do some quick scratch paper. Might even be faster than pulling out the calculator. Maybe so, maybe no. The signs are the same, so you add and keep the sign. So b equals -28/3. Does it reduce? Does 3 go into 28? Nope, it doesn't reduce. So there's your answer. Our answer is y equals 2/3. That's our slope. X minus 28/3. Did I make a mistake? Was that answer supposed to be that ugly? Give me a second. Let's see. Let's find out, shall we? Yep, it was supposed to be that ugly. Good. I was afraid I'd lied to you and made some random mistake that I didn't catch that y'all were going to tell me about in class later. But that's it. And that's it for the notes. Now, this one specifically was perpendicular. If it was parallel, we would do the same process, but we wouldn't have to flip it over. It would just be the slope, right? And if it gave you the line in not slope intercept, we'd have to start by getting it in slope intercept. Then we would have the slope. Then we would use it, right? All of these puzzle pieces kind of go together, and we just kind of fit them all nice and pretty. One of the reasons I like math. If you're one of my students, thanks. I'll see you in class. Do your homework, all of those things. If you're not one of my students, thanks for joining us. Let us know how else we can help you with math or science or homeschooling in general. Have a great day. Bye-bye.